Dear colleges, we offer you a report on analytical and geometric interpretation of the flat arrangement of points by means of metric geometry in the study of metric spaces. The work considers the issues of studying methods of geometric properties of metric spaces in higher school. First, we introduce some basic concepts related to metric spaces. Such concepts are metric space, points of space, distance between points of space. Let in the set X of elements X, according to a certain rule ρ, any two different elements x1 and x2 of this set can be matched with a single real number ρ x1, x2, so that the conditions are fulfilled. 1, 2, 3. Then such rule ρ is called the metric of the set X. The set itself is called the metric space with the metric row and denoted by x row. The numerical value row x1, x2 is the distance between the elements x1 and x2, and the elements themselves are the points of the metric space. More compactly, this distance between the points xi and xj is denoted by rho ij. The authors also use the concept of an angle in metric space and the concept of a numerical characteristic of an angle. By the angle formed by 3 points xi, xj, xk, we will understand the ordered triple of these points xi, xj, xk, and denoted angle xi, xj, xk. At the same time, the point xj will be called the vertex of the angle, and the pairs of points xi, xj, and xj, xk are its sides. The numerical characteristic of the angle xi, xj, xk will be called the number phi xi, xj, xk, formula 1. Or more compactly, pi I, J, K, formula 2. With the help of the concept of the numerical characteristic of an angle, it is possible to write down the definition of the flat placement of 4 different points of the metric space. We will say that the 4 points x1, x2, x3, x4 of metric space x row are flatly placed in this space if the equality holds. Formula 3. The equality in Euclidean geometry means that the volume of the tetrahedron whose vertices are located in the points x1, x2, x3, x4 is 0. Any of these points can be chosen as the common vertex of the angles. If any 4 points of some set of metric space are flatly placed in this space, then this set of points will be called flatly placed in this space. Let us give an example of a flat placement of points in metric space. In the space C, we take 4 points or functions y1, y2, y3, y4. Distances between these points in space C is numerical characteristics of angles with the apex at point y4 is. Let's calculate the determinant is 0. Therefore, the points y1, y2, y3, y4 are flatly placed in the space C. In the two-dimensional Euclidean space R2, the points y1, y2, y3, y4 are linear functions and are placed as follows. To visualize the mutual location of 4 points A, B, C, S of matrix space, the distances between which are known, let's build the corresponding tetrahedron ABCS in the dynamic geometric environment of GeoGebra 3D. We place vertex A in the center of the three-dimensional system of Cartesian rectangular coordinates space R3 and vertex B on the positive semi-axis of the abscissa. When calculating the coordinates of the vertices of the tetrahedron, the ordinate of point C and applicate of point S will always be non-negative. The coordinates of the vertices of the tetrahedron can be calculated using the formulas. When calculating the coordinate ZS, the Jungius formula was used. Jungius formula is an analog of Heron's formula. It is used to calculate the volume of a tetrahedron by the length of its edges. If the lengths of the edges of the tetrahedron are denoted by A1, A2, A3, A4, A5, A6, then the square of the volume of this tetrahedron is calculated according to the Jungius formula. With different orientations of the tetrahedron, different values of the square of its volume are obtained. They can be positive, indicating that such a tetrahedron exists and can be constructed. If the square of the volume of a tetrahedron is negative, then this indicates that such a tetrahedron does not exist. If the square of the volume of the tetrahedron is equal to 0, then all the vertices of the tetrahedron lie in the same plane. That is, they are flatly placed. These values are calculated on a special calculator, which, using the Jungius formula, calculated the value of the square of the volume of the tetrahedron at different orientations. In the space R3, you can visualize the mutual location of the 4 points y1, y2, y3, y4 on the space C, which were considerable. For this, it is convenient to use the dynamic geometric environment GeoGebra 3D. Using the formulas of the coordinates of the vertices of the tetrahedron ABCS, we will obtain the following image of this tetrahedron. Since this image is placed on a flat screen, it does not give an idea of the spatial relative location of these 4 points. The dynamic geometric environment of GeoGebra 3D makes it possible to rotate tetrahedron images in such a way that their flat arrangement becomes obvious. To do this, it is enough to select the point of observation of the tetrahedron in the X or Y plane. By rotating the image accordingly, we get the following image of all 4 points. This image shows them flatly placed. This is conclusions from our work. Thank you for your attention.